In this video, I want to show you how to graph a linear equation. To do that, you need to be able to sketch a coordinate plane. The coordinate plane has an x-axis and a y-axis. You need to be able to label the point where the axes intersect in two ways. That point is the origin. It is known as the coordinate pair 0, 0. It's the starting point for our graphs. You need to be able to use Roman numerals to label the quadrants. So quadrant 1 is to the right and up from the origin, and then the quadrants are numbered counterclockwise around the origin. You need to be able to write an ordered pair in each quadrant using signs. So to get to quadrant 1 from the origin, I'd have to go right and up. So right is positive, up is positive. So all the points in quadrant 1 have positive coordinates. But to get to quadrant 2 from the origin, you'd have to go left and up. Left is negative, up is positive. So all the points in quadrant 2 have a negative x coordinate but a positive y coordinate. In quadrant 3, both coordinates are negative, and in quadrant 4, the x is positive and the y is negative. In order to graph an equation, one of the skills that you need is to be able to solve the equation for y. Let's solve this equation for y. To solve for y, I need to get rid of the 5x. It's added to the y term, so I'm going to add the opposite. Then I'll need to get rid of the 3. It's multiplied, so I will divide. Let's do those mentally. So I'm going to add a negative 5x to both sides. Now I'm going to divide both sides by 3. Now let's do a written check. So if y is really negative 5 thirds x plus 7 thirds, if I put this expression in place of y, as you see here, then it should make the equation true. Notice to simplify here, I need to use the distributive property here. The 3's are going to cancel, and I'll be left with a negative 5x, and then I also have to multiply the 3 times 7 thirds. The 3's again will cancel, and I'll be left with the 7. Then 5x plus negative 5x gives 0, so you're left with the true statement, 7 equals 7. So I know that y equals negative 5 thirds x plus 7 thirds is the solution. Again, I want you to be able to graph a linear equation in two variables. So what is a graph? A graph is a picture of the solutions to an equation. I want you to keep that in mind. It's a picture of all the ordered pairs x, y that make the equation true. A graph also shows the relationship between the input, or the independent variable x, and the output, or the dependent variable y. Looking at this graph, well, what color is the graph? Well, the graph is yellow. Now you also see the white lines, you see the x and y axes, but that's just the background for the graph. The graph itself is yellow. Looking at the graph, I can tell that as you go to the right on the graph, that x is increasing, because we always put our positive numbers to the right, so x is increasing. But notice as x is increasing, y is increasing. So I can see, by looking at this picture, I can see the relationship between x and y. How many solutions does a linear equation have? Well, let's just check one. Is negative 1, 3 a solution to this equation? If it is, then if I put a negative 1 in for x and a 3 in for y, it should make the equation true. But it doesn't. So the ordered pair negative 1, 3 is not a solution. So does this equation have a solution? And if it does, how many? Well, I said I wanted you to be able to graph a linear equation in two variables. All the equations that we're going to graph or draw pictures of will have two variables, an x variable and a y variable, and they're called linear equations because they have so many solutions. Well, there are an infinite number of solutions, And the solutions always line up. They always line up. So that's why they're called linear equations. Now, I'm eventually going to show you 3 ways to graph an equation. In this video, we're only going to look at the first way. The first way I want you to be able to graph an equation you should already be familiar with, but it's by making a table of values. Now, there are 3 steps to graphing by making a table of values. Step 1 is to solve the equation for y if necessary. Step 2 is to choose some x's or inputs and use those to calculate the y's or the outputs. And last of all, to plot the points on a coordinate plane. Now, there are 2 other ways to graph an equation we're going to look at, but we'll do that in another video. So let's graph this equation by making a table of values. To do that, we need to first solve the equation for y. So I need to get rid of the 6x that is added to the negative 3y by adding a negative 6x to both sides. Then I need to get rid of the negative 3 that is multiplied by dividing both sides by negative 3. So my equation is really, in simplest form, is really just y equals 2x minus 4. Now I'm ready to make the table of values. I get to choose the x's. Now I'm going to choose 3 x's. It actually only takes 2 points to determine where to draw a line, but I'm going to choose 3 because I like to have one as a check to make sure I've done the other 2 correctly. Since I can choose the x's, I'm going to choose what I consider the 3 easiest x's or inputs. I'm going to choose negative 1, 0, 1. So all I have to do is take those inputs, put them into the rule. This is the rule for the equation, and do the calculations. So here, 2 times negative 1 is negative 2, and negative 2 plus negative 4 is negative 6. Now I'm going to do that for each one. So I'll come up with my outputs, and then I'll put my inputs and outputs together in an ordered pair that I can now plot as a point on a coordinate plane. So I'm ready to plot these 3 points. Now, when you start to draw your coordinate plane, it might be wise to first look back at your inputs and outputs. My inputs, notice, are small, but look at the outputs. They're all negative numbers. So on my coordinate plane, I know I'm going to need a lot of space in the negative part on the y-axis. So I probably want to draw my coordinate plane like this, and then plot the 3 points, and then connect them, because you see these are not the only 3 points that are solutions to the equation. Every point on the line that you can draw through those 3 points is a solution. So how many solutions does this equation have? An infinite number, as indicated by the arrows on each end. So every point that is on this line is a solution to that equation. Let's check one. Let's check that one because it's a fairly easy point to check. That's the point 2, 0, because it's 2 spaces to the right of the origin, but it's not up or it's not down. Is 2, 0 a solution to this equation? Well, it should be, because it's on the line, it's on the graph. The graph is the red part here. It's on the graph, and what is a graph? It's a picture of all the solutions to the equation. But let's check it algebraically. So let's put 2 in for x and a 0 in for y, and see if it makes the equation true. Well, it does. So therefore 2, 0 is a solution to this equation. Now what do I know about this point? Well, I know this point is not on the red line. What does that mean? It's not on the graph. What is the graph? It's a picture of the solutions. So since this point is not on the graph, this point is not a solution for this equation. Now we could check to see what this ordered pair is. It's 1, 2, 3, 4, 5. It's negative 5, 3. So if I were to put a negative 5 in for the x and a 3 in for the y, algebraically it should not make the equation true. Now, suppose I ask you to graph this linear equation. Notice it's already solved for y, so I'm ready to set up my table of values. Again, normally here for my x's or for my inputs, normally I would choose -1, 0, and 1. However, notice here that the x is multiplied by 4/3. If I choose the x's -1, 0, and 1, when I multiply two of those, the -1 and the 1 times 4/3, I'm going to get a fraction. And then I'll have to add that to 2. And so that's going to make my work harder, having to deal with a fraction. Therefore, I would like to choose some easier x's, so I'm going to choose -3, 0, and 3. Now the reason I'm going to do that is because if I let x, for example, be -3, then when I multiply -3 times 4/3, look what's going to happen. The 3's are going to cancel, and I'm just going to be left with the number -4. 4 times 1 is 4, 1 times 1 is 1, 4 over 1 is 4, the signs are different, so the answer is negative. And now -4 plus 2, so my output is going to be -2. So always make it easy on yourself when you notice there are fractions in the problem by choosing inputs that will make your calculations easier.